Hi everyone, in this video I'll be going over implicit differentiation in AP Calculus BC, and let's get started. So the general definition of implicit differentiation, or why we use it, is this definition here that I found in my review book, and it reads, given an equation containing the variables x and y in which you cannot easily solve for y in terms of x, you can use dy over dx to solve for the equation. So in simpler words, this basically means when we're given an equation that contains more than one variable, usually x and y, it basically means that we can solve for y by using implicit differentiation. And what I mean by that is I'm going to show you an example in the following page. Here are some general steps to approach an equation using implicit differentiation. So the first step is usually to differentiate each term of the equation with respect to x. So that basically means take the derivative of each term. The second step is to move all the terms of dy over dx to the left-hand side and all the other terms to the right-hand side. Following step is to factor out the dy over dx, and finally you can easily solve for dy over dx once you factor it out. And now it's time for the example, if you're actually very confused even with these steps. So here's an example of an equation that needs implicit differentiation in order to solve for dy over dx. So how do we do this? The first step, like we mentioned before, is to take the derivative of each term. And when we do that, for the first term, y squared becomes 2y. However, we also have to add the dy over dx because we treat y as a function of x. Then it's the negative 7y, which becomes negative 7 dy over dx. Following that, it's plus x squared, which becomes 2x. Following that, it's negative 4x, which becomes negative 4. And lastly, you have the equals 10, which becomes 0. Following this step, we move all our dy over dx terms to one side and our 2x minus 4 terms to the other side. So this will become 2y over dx minus 7 dy over dx is equal to negative 2x plus 4 because we move it to the other side. So following this, we can go ahead and factor out our dy over dx, which becomes 2y minus 4 equals to negative 2x plus 4. Minus 7, sorry. And lastly, we can solve for dy over dx by dividing 2y minus 7 on both sides, which will become dy over dx is equal to negative 2x plus 4 over 2y minus 7. That is your answer. However, I'm going to do another example that requires an extra step, which we will probably see in the APBC test. If you're lucky, you might see a basic example like this also. So what we have here is x cubed plus y cubed equals 6x y. So automatically, if you're thinking, okay, we have to take the derivative of each term, you're on the right path. However, we have to realize that 6xy requires the product rule when we take the derivative. That's something that will usually come up. And in this case, we have the product rule, but in other cases, you may have the quotient rule. So let's do the product rule for this. this will become 6x. We have to do u substitution. So u is 6x, u prime is 6, v is y, v prime is dy over dx. And a quick trick of when we add dy over dx, if you're wondering, is I like to think of whenever I see an y variable, automatically I know that dy over dx has to be included. So keep that in mind if you're having trouble with dy over dx. Okay, moving on. Now that we have that, we can go ahead and continue with our u substitution, which will become 6y plus 6x dy over dx. So that is our new way to, well, that's our derivative of 6xy. So moving on to this area of the question. So for this part, we can easily take the derivative, which becomes 3x squared plus 3y squared dy over dx is equal to 6y plus 6x dy over dx. So now we continue with the with our general steps that we listed in the previous page. So this will become moving all the dy over dx terms to one side and moving all the remaining terms to the other side. So this will become 3y squared dy over dx minus 6x dy over dx is equal to 6y minus 3x squared. So moving on, we can go ahead and factor out our dx over dy, which will become dy over dx, which will become 3y squared minus 6x is equal to 6y minus 3x squared. So finally, we can go ahead and divide 3y squared minus 6x on both sides. And when we solve for dy over dx, our answer should be 6y minus 3x squared over 3y squared minus 6x. That is your answer. I hope you had a great time watching this video, and hopefully this short video helped you with implicit differentiation if you're having trouble. And thanks for watching.